Let's write a program to implement priority queue. These are include libraries. Hash include stdio.h includes the standard input-output library for function like printf and scanf. Hash include stdlib.h includes the standard library for functions like malloc and free. This defines a constant max size with a value of 100. This constant is used to define the maximum number of elements the priority queue can hold. Now write the structure definition. This structure defines an element that contains two members, data, an integer representing the actual data or value, priority, an integer representing the priority of the element. Here the element structure can be used to create variables that hold both data and value and its corresponding priority, which is useful in priority queues where elements are processed based on their priority. And this structure defines a priority queue that contains two members, elements, an array of element structures. The max constant defines the maximum number of elements priority queue can hold. Size is an integer representing the current number of elements in the priority queue. The priority queue structure can be used to manage a collection of element structures, where each element has a specific priority. The size member keeps the track of how many elements are currently in the priority queue. Now initialize the function. Here init priority queue initializes the priority queue by setting its size to 0. Write down the utility functions. Here the swap function swaps two elements. This is the helper function used to maintain the heap property during the enqueue and dequeue operations. Now write the function to heapify up. The function heapify up ensures the heap property is maintained after inserting a new element. It recursively swaps the new element with its parent until the heap property is restored. PQ is a pointer to the priority queue, index of the element in the heap array that needs to be moved up to the maintain the heap property. Now we will write the heapify down function. This function ensures the heap property is maintained by comparing the priority of a node with its children and swapping if necessary, then recursively calling itself on the largest child. It takes two parameters, a pointer to a priority queue structure PQ and an integer index representing the index of the element to start heapifying down from. And it calculates the indices of the left and right children of the current element using the simple binary heap indexing. It initializes a variable with current index assuming that the current element is the largest among the parent and its children. It checks if the left child exists and if its priority is greater than the priority of the element at largest. If so, it updates the largest to the index of the left child. It also performs a similar check for the right child, if it exists, updating the largest accordingly. If largest is not equal to the original index, it means that one of the children has the higher priority than the current element. In this case, it swaps the element at the index and largest to maintain the heap property. Finally, if a swap occurred, it recursively calls heapify down on the index where the largest element was moved to the largest. This ensures that the heap property is maintained down the tree until no further swaps are needed. In the essence, heapify down syncs the element at the given index down the heap until it finds its correct position, ensuring that the heap remains ordered according to the priority. Now let us write the code for enqueue. Priority queue is a pointer to the priority queue where the element is to be added. Int data. This is the data value of the element being added. And int priority. This is the priority associated with the element being added. It starts by checking if priority queue is already full. If the current number of the elements in the queue is equal to the max, that is maximum capacity of the queue, it prints a message indicating that the priority queue is full and then it returns without adding the new element. If the priority queue is not full, it proceeds to add the new element. It assigns the data and priority values to the element at index PQ in the elements array of the priority queue. Since the queue is 0 indexed, this effectively adds the element at the end of the array. Then it increments PQ to reflect the addition of the new element. After adding the new element, it calls the heapify up function to ensure that the heap property is maintained. It passes the priority queue pointer PQ and the index of the newly added element. Heapify up is responsible for moving newly added element up the heap if necessary to maintain the heap property. So in summary, NQ adds a new element to the priority queue by assigning its data and the priority values, increments the size of the queue, and then ensures that the heap property is maintained by calling the heapify up on the newly added element. After NQ, now let's write code for DQ. Here priority queue PQ is a pointer to the priority queue from which the element is to be removed. It starts by checking if the priority queue is empty. If PQ, the current number of the elements in the queue, is equal to 0, it prints a message indicating that the priority queue is empty, and then it returns -1, indicating an error or lack of value. Heapify down is responsible for moving the new root element down the heap if necessary to maintain the heap property. Finally, it returns the data value of the element that was removed, which represents the data of the element with the highest priority that was dequeued. So in summary, dequeue removes and returns the element with the highest priority from the priority queue, maintains the heap property, and handles cases where the queue is empty by printing a message and returning -1. Now write the code for peek function. This function takes a pointer to a priority queue structure as an argument and returns an integer. The function first checks if the priority queue is empty by examining the size attribute of the priority queue structure, that is PQ size. If PQ size is 0, it means the queue is empty. In this case, the function prints a message, priority queue is empty. After printing the message, the function returns -1 to indicate that there is no element to peek at because the queue is empty. If the priority queue is not empty, the function proceeds to access the element with highest priority. In a binary heap implementation of priority queue, the element with the highest priority is always at the root of the heap, which is located at index 0 in the elements array of the priority queue. The function returns the data value of the element at index 0, that is PQ elements of 0 data. After peek, now we will write the code for isEmpty function. This function returns whether the priority queue is empty by checking if the size is 0. Now let's write the main function. Here the main function demonstrates the usage of the priority queue. Priority queue PQ declares a priority queue. Init priority queue ampersand PQ, this initializes the priority queue. These lines inserts the elements into the priority queue with specified data and priority. This dequeues the elements from the priority queue and prints them until the queue is empty. Returns 0 to indicate successful execution of the program.